Now next, parallel connection of resistors. Suppose the resistors are connected between two terminals A and B as shown in the figure, such that the current I have different paths to flow from A to B. Then this type of connection, that is the parallel connection of resistors. Here suppose across these two terminal A and B, the potential difference of V volt is applied, or in other words we can say, suppose between A and B the battery having V volt is connected, which constitute current I in the circuit. So when this current I reaches to this junction, then it will be divided in three parts. Suppose I1 current is flowing through resistor R1, I2 current is flowing through resistor R2, and I3 current is flowing through resistor R3. And when all these three currents reaches here and comes out from this connection, then again the total current that will be I. And here, see, suppose we think about resistor R1, then one terminal of resistor R1 that is directly connected to A, and the second terminal of R1 that is directly connected to B. In the same manner, R2 and R3 are connected. So, the potential difference in parallel connection of resistor across each resistor will be same one, but the current through each one will be different one. Now see here, at this junction, total current I is distributed as I1, I2, I3. So we can write I, that is equal to I1 plus I2 plus I3. Now I, that is V by R. So as per that we can write current I1 that is equal to V by R1, current I2 that is V by R2, current I3 that is V by R3. Take V common from this one and take it on left hand side. So we can write I by V that is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Clear up to this one? Now, suppose the equivalent resistance of this entire connection, that is R, it implies that if this connection of three resistors that is replaced by only one resistor having resistance R, then the same voltage will constitute the same current. Then we can say that resistance R is the equivalent of this combination or connection. So if equivalent resistance is R, then we can write R equal to V by I. So we can write 1 upon R, that is I by V. So in this equation, if we replace I by V by 1 upon R, then we can write the equation 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So using this equation, when we calculate R, then we can say that is the equivalent resistance of this parallel combination of resistors. Suppose we have n resistors in parallel connection, then the equivalent or the resultant resistance for that, we can write the equation 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 up to 1 upon Rn. Now here, if all the resistors connected in the parallel combination are with same value, means if R1 that is equal to R2 that is equal to Rn that is R dash, then we can write 1 upon R that is equal to 1 upon r dash plus 1 upon r dash plus 1 upon r dash up to n times. So resultantly, we can write 1 upon r, that is n times 1 upon r dash. So we can write r, that is equal to r dash by n. And always remember this thing, in parallel connection of resistors, the resultant or equivalent resistance that will be smaller than the smallest one connected in the combination. Clear to all of you? Now here one simple example is given to you in which three resistors are connected between two terminal A and C as shown in this figure. And now here, suppose we want to find the resultant current flowing through the circuit I, or we can say we want to calculate the current I constituted by the potential difference of V volt across A and C. Then first of all, we have to calculate the equivalent resistance of this combination. So here see, R2 and R3, these two resistors are parallel. So we can prepare the equivalent circuit like this. Replace these two resistors which are in parallel, R2 and R3, by one resistor which is equivalent to this combination. Suppose that resistor is R23. So we can write R23, that is equal to R2 R3 upon R2 plus R3. So now this particular circuit we can prepare like this. A to B register R1 as it is, and B to C, this parallel combination is replaced by one register R23. Now you can understand here this register R1 and this register R23. These two are in series. Suppose the equivalent register of this series combination is R. Then finally our equivalent circuit, that is A to C, only one register R. And this register R equal to R1 plus R23. Now substitute the value of R23. So we can write R1 plus R2 R3 upon R2 plus R3. Now current in the circuit I, that is equal to V upon R equivalent. So V by R, that is equal to V by R1 plus R2 R3 upon R2 plus R3. So in this way we can simplify the circuit. Clear to all of you?